Now we got another customer. This is another customer, which means we're going to have another VRF. Yeah. I just want to explain you something before that. You see, this one is going to be another VRF. Each customer need to have their own control plane. Yes? Did you understand what is control plane? See, control plane is maybe a table or information that is going to drive the packet. The routing table drives the packet towards the destination. So routing table is a control plane. Now, do you have a control plane for customer R1, R2? Yeah, we should be able to ping now. Let us ping and test between R1 and R2. Likewise, I need another control plane because this is another tenant, another customer. So we are going to create another VRF. Now, why I'm saying that again? You see, I'm going to use different. I'm going to use the same subnet, not the different subnet, just to prove you that. Oh my God! Just to prove you that because they are in two different control plane, this 192.168.0.0 is not same as this 192.168.0.0. You understood? So even this one can be a duplicate. Now, do you remember what route distinguisher we gave on R3? No problem. Now, on R3 show IPVRF, you see this is what the route distinguisher we have. Yeah, so what I'm trying to say here is for this customer, it is going to be 1:1 192.168.0.0/24. This is how it provides that uniqueness. And for the other one, other customer, which is R7-R8, it is going to be, I'm going to give route distinguisher maybe 2:2. Now, if you see, this is not this. Is it? Are they same? No. In the VPN tunnel, they are not seen as 32-bit address. It is 32 plus 64. 32 plus 64, 8 byte. It's 8 byte, 64. 32 plus 64. This is 96-bit value. This is another 96-bit value. They are not the same. If you remove this route distinguisher, they look same. Because you have different route distinguisher, they are in different control plane. The control plane of R1 and R2 is identified as 1:1. What is the identification for control R7 and R8? Yeah, that's why we call it as route distinguisher. Now let us go to router 6 and see what we have given. Show IPVRF. Here we have given 2:2 for the same customer. Is this allowed? Of course it is allowed. You can have route distinguisher for the same customer, a different one. You can also have the same one. What I'm trying to say here is, it is not necessary to be same. Why? Say something, no? Why? Because route distinguisher is locally significant. See, you know already. Now, I'm going to give another route distinguisher for this one, maybe 22:22. And this one, I would like to put 1 here. Same subnet. They don't conflict. They don't conflict because the addresses, the subnets, the prefix length in the tunnel is 96 bit. It is not 32 bit. Now, what about the route target? I told you route target is the value which is used as the community tag. All that coming from R1 as an advertisement, all that is coming from R1 as an advertisement is tagged with a number which is called export value. Route target export. Wherever you want that to be downloaded, you need to use the same community value as import. You remember when we did community, we were matching that number on the service provider side and we assigned a local preference value there. Here we are not going to give local preference. We are just importing into the customer's routing table. So let us see what route distinguisher we have given on R3. Show IPVRF detail. We have given export and import value 1:1 for this customer. Both import and export is 1:1. This 1:1 and route distinguisher 1:1, is it necessary to be same? Not necessary. They are totally different. Though the size is same, 64 bit, but they are not necessary. They need not to be same. Now what I'm going to do here is, for export, I'm going to use different tag value. I'll say 22:22, which means in here I need to say import, isn't it? And all that I'm learning from R8, I want to export with some value. I'm going to say 2:2, which means here I need to say import 2:2. So now this should be more meaningful for you after community class. Next, as we already discussed, let us go and ping between R1 and R2 and see whether the ping happens. Okay. Show IP route. Do you learn the BGP route? Do you see a BGP route? Yeah, this is coming from where? Let us check. Show IPBGP. How do you learn it? You're learning from EBGP, and the autonomous system via which you are learning is 20 and 10 path vector protocol. So now let us try pinging. And not only that, you see here, the AS path, local is 30. Local is 30, right? Hmm. And also, when you check the administrative distance, it's only 20. So let me try. Tell me what. Okay. 192.168.0.1 with a source of 192.168.1.1. Let me check. Show IP. Okay, the IP address is correct. Here is correct. So let me try pinging again. See, if you are learning the route and if the ping is not happening, the problem is not with the control plane. The problem is with the data plane. For what all reasons the data plane will will have this issue? Maybe somewhere Ceph is disabled, or maybe we did not say update source somewhere, something like that. So layer 2 is broken. I'm going to check that. I want to go to router 6 and check. Show IP route BGP. Sorry, show IP so run section IP, no, router BGP. Okay, here we have used and we have activated, and I did not give this command. This will automatically come whenever you have VPN. This is good. This is also this. See, this one I did not give this command. I repeat, when you are checking in your production, if you see this activate, don't think that the engineer has done this. No, we did not give this command. Okay, I remember you asking some other day this question. Maybe you or I don't know which student. It is not given by your engineer. It will come automatically. Whenever you are doing this in the address family, IPv4, VRF, this activate command will come automatically. I did not activate this. Now, R3, show run section IP, sorry, router BGP. No, you don't have any network advertised from router 3. Have you? Have you advertised? See, you can ping only this. You can only ping this. That you can ping. See, if this ping is not happening, neighbor would have not come up in the first place. You already got the routes, understand? R1 and R2 has already got the route. So you should not waste time pinging these things. You should not waste time pinging like this in exam. Here it is okay. Now, this is something related to MPLS and SIF. Let me go again to R3 and check MPLS. Show MPLS LDP neighbor. Are they using loopbacks? Yes, they're using loopbacks. Show MPLS interface brief. Interfaces. On F1/0, it should run. It is running good. You cannot run MPLS on loopback interface. You see? Don't try that. It's waste. Not necessary because the LDP cannot distribute routes over the virtual interface. So let me go to R4. See, there is some issue with the LDP. I can see that. Just for 19 seconds only it is up. What was long back? See, long back we brought it up. But between router 3 and router 4, it has just come up. This is the one. The address with which you are forming neighbor, no? It needs to be 32. Why? Why? Because your router IDs are 32-bit. You agree? What happened? Any distraction? I repeat. I want to repeat again. Try to follow. When you are having /24, it is only 6.6.6.0. It is not 6.6.6.6. But all the router IDs are 6.6.6. Router IDs. Where is router ID 24? No protocol has got 32. So interface loopback 0. That's why it is breaking the data plane. IP address 6.6.6.6.255. I remember we corrected this. I don't know how. LDP is coming up with 32 mask. Earlier it was. So the LDP will go down and come because earlier it was using 6.6.6.0 as the router ID, but now it is using the router ID all 6. So now let us try. Go to router 2 now and check. Check pinging. You see? Did you see? But when you ask this type of question in interview, most of them will not understand the question first. It is very difficult to make them understand what we are trying to ask. This type of questions are not that easy to make them understand. Because this is something related to data plane. Router ID must match with the neighbor address. BGP is considering the neighbor as /30/24, but all the router IDs are 32-bit. So the route ID and the BGP peering is not matching. For the control plane and the data plane to work together, the router ID and the BGP neighborship address must match. OSPF, BGP, MPLS, all these uses that all three should have the same router ID, plus the BGP peering address that you give also should be same. You understood? If that is not same, you see IP address was same, but the problem is the mask. So in simple, what I want to say here is, if you're doing layer 3 VPN, between the PE routers, make sure you have 32 mask. Yeah. Now, shall we go to next customer? Okay. On the next customer, this address can also be same. You want me to have same address or different address? Come again? Doesn't matter? Okay. Then I'm going to have the same address. But this time we are going to do with different protocol here. OSPF. Area. Anything. Area 222 or 777. And here it is going to be area 888. In the middle, what do you have? What OSPF you have? We have OSPF area 0. But my question is, does that matter? No, no, not at all. Why? This is in different control plane. This is for customer VRF. You understood? Now I want to ask you a question. Without area 0, can these two areas share the routes? How? Very nice answer. I appreciate. So how technically people answer this? Technically, you need to give answer like this. The tunnel is considered as super backbone. That's the word they use. The VPN tunnel is considered as super backbone. That's the word they use. You understood? Okay. Super backbone. Yeah. When you use that term, no, they will understand that you learned proper. But what you said is also correct, because it is going through the tunnel. You will be redistributing from OSPF to BGP and vice versa. So that's a very straightforward answer that you gave. But people will be more satisfied if you say this word super backbone, because that is what mentioned in the book. Super backbone. Okay, so I would like to start from router 7. I'm giving even the host address same, okay? 1.0.1. Area 777. Right, I'm not running BGP, I'm running OSPF. Yep. Let me go to router 8 now. Uh-oh, I'm put wrong area ID. What is the area ID? 888. Okay, now let's go to router 6. On router 6, first of all, I need to create a VRF. IP VRF. What's the name that we decided to use? Cust-R7-R8. And then route distinguisher 22 colon 22. Route target export. No. See carefully. I mean R6. What is export? No problem. Route target import. Done. Now let's go to the interface. Which interface? Yeah. Now put the IP address. What's the IP address on this interface? 26 dot. And what is the protocol that we are planning to run? Do it under the interface. The interface is already in the address in the VRF table, isn't it? So instead of doing OSPF globally, better do it here. Huh? IP OSPF 1. Don't use 1. If I use 1, see what happens. Okay, I'm using 1. See what happens. Area. You see, it will not accept. Sorry, VRF specified is not accessed. 1 minute. I think I gave a wrong VRF name. This is the VRF name. See, IP OSPF 1 area is here. Specifically, it does not match the existing router. Okay, forget about this. This is something. This is actually related to the process ID. Okay, we have already used OSPF process ID 1 in this router for ISP, isn't it? So I should use different number. That's all. See, it accepts now. So this error message is faulty. It should say the process number is already being used. When I say 1, it should say the process number is already being used. Yeah. So that's faulty. That's not nice. So the neighborship has come. Let us go and check the VRF table. Show IP route VRF cust -R7 -R8. You see, you got the route. Now, to place this in the VPN, what we have to do is you need to go to router BGP 20 address family IPv4 VRF cust -R7 -R8. Do you follow me now? Redistribute OSPF process ID 2. That's it. Does that matter? Did you understand this? Did you understand this? Okay. So now it goes through the VPN. It is getting advertised into VPN. Those router 8 routes are going through the VPN. Now to import that, you need to go to R3 and create a VRF, IPVRF, cust is -R7 -R8. Route distinguisher, what is that we discussed? 2:2. Route target export is 22:22. Route target import 2:2. Now you need to import the route. So what I'll do is I'll go to router OSPF. I need to create another OSPF here. Router OSPF 2 for the VRF. Do you follow what I'm saying? R7, R8. Redistribute BGP 20 subnets. Process 2 failed to allocate. The reason is we don't have any interface in process ID 2 on this router. So we go to the interface via interface F1/1, IP VRF forwarding, cust -R7 -R8, no chat, IP address 13.13.13.3. Now it will work, okay? Which will work, the IP OSPF. Now let us also run OSPF. IP OSPF process ID 2, area 888. Now, let's go and see whether the redistribution has happened. Show IP route for customer. You see, we have learned this 26 and 192.168.1 from the remote site. The redistribution is working. From via the tunnel, BGP only receives it, right? Now, To check whether the redistribution really works, I need to have a neighbor. Do I have a neighbor? Show IP OSP of neighbor. There is no neighbor. I made a mistake. You know what mistake I made? In R3, I've given area ID as. That's why. That is why. That is why. No, that's okay. See, it's working. Now I must see the route on R7. Show IP route. You see? But you will not be seeing R7 route on R8. Can you tell me why? We have imported. You see, show IP route. See, we have imported. Let me show you in R6. We have given, but you are partially right. But the word that you used is not correct. Show IP VRF detail. You see, you have imported. You have imported for 7 and 8. You have not redistributed from BGP to OSPF. You got it? From BGP to OSPF, we have not redistributed. Yeah. So we need to say router OSPF2, which is created for VRF cust -R7 -R8, redistribute BGP 20. Don't forget to type subnets. Did I say subnet on R3? Let me check. Show run section. Huh? Yeah, I have given. So in R6, also I use the keyword subnet. Now it's the time for testing. Wait, the routes have not come. You know what? Still on R6, I have not completed. Hey, I did. Then we need to wait. Show IP route VRF cust -R7 -R8. Is this coming? No, this is. We are not learning. We are not learning anything. Maybe there is some issue with the import and export. Let me check. Did I export on R3? Go to R3. Show run router BGP. Did I redistribute from OSPF? No redistribution is done. Sorry, not here. Correct. Correct. There is no redistribution done in one direction. So we need to go where? Router BGP. Wait, where is the new VRF that we created? There is no VRF created here. Show IP VRF. Oh, here it is. Router BGP 20. Address family IPv4 VRF. Redistribute OSPF process ID 2. That's it. This is what missing piece. Now, if you go to router 6 and check the routing table, you have the routes. Do you have the route? Have you received the route now? Yes. Let us try pinging the remote address. This is the remote site address. Yes or no? I'm able to ping. Now, let me try with the source loopback 0. I'm able to ping. Please pay attention. I'm going to trace route from R8. See the path taken. It goes to whom? What is the final destination? To which router it goes? See the last number, the host portion. 7. Now, same thing, I'm going to paste it on router 2. Same destination, but it is not truly the same destination. See where it goes. Different control plane. The VRFs keeps the customer's route unique by attaching the route distinguisher. Correct, right? You understood that point, right? Did you understand that point? Route distinguisher makes this possible. Route distinguisher makes this customer's route unique, even though they look same when you compare the 32-bit. Route distinguisher gets added to the 32-bit and it is unified. It is made unique. Do you agree with that? Okay. Like we have used OSPF, you can also use EIGRP on router 8, RIP on router 7. You want me to do and show you, or will you try this weekend? But you don't, you try of your own because you have seen it. Okay, so you're going to change R7 routing protocol as RIP, R8 routing protocol as EIGRP. And when you find some difficulty, let me know. Okay. Now,